Hi, everyone. Thank you for joining us for today's webinar, Cutting Edge Functional UI Testing Techniques with Adam Carmi. Before Adam kicks off, I'll just give a brief intro. Adam is the co-founder and CTO of Applitools. He has over 15 years of technological leadership and innovation experience under his belt. Prior to founding Applitools, he held management, research, and development positions at SafeHand, IBM, Microsoft, and Intel. Adam holds a bachelor's and a master's degrees in computer science from the Technion, and he regularly talks about software testing at conferences around the world. Adam is also the founder and organizer of the Israeli Selenium Meetup Group. So without any further ado, Adam, the stage is yours.
Thank you very much, Adi, and hi, everyone. I'd like to repeat these words from before and thank everyone that joined us in this interesting times. I hope that you're all doing fine and your families and continue to do so in the coming days. So let's talk about functional UI testing techniques to take your automation to the next level. It's no secret that many teams struggle with automated functional UI testing, some to the point where it is completely abandoned despite the fact that the UI is the most important interface of the system. From what I see, even teams that experience initial success, they quickly find themselves unable to retain high test coverage as the overhead of maintaining existing tests and analyzing test results increases over time. So in this session, we will introduce a new technique for implementing automated functional tests that eliminates most of the downsides of the traditional approach. Now, this technique is based on the advanced computer vision technology that powers our visual testing service, and it has been successfully used for several years by our R&D team for testing our own product and by many other teams around the world, and I'm sure that you'll find it very useful as well. So we have quite a lot to cover. We'll start by reviewing the main challenges that teams are having with the traditional UI testing. We'll then explain how you can do efficient UI testing with Visual AI, tell you a bit about Visual AI, what it's all about, and then we'll cover how to effectively perform cross-device and browser testing with Visual AI and the ultra-fast GUI. So I'm sure that you will agree with me that the #1 priority when it comes to automation for most teams is basically to increase functional test automation coverage to safely speed up release cycles. Now, different teams have different motivations to speed up release cycles. Some really need to release code to production several times a day. Some just want to be ready to release when needed, and some just want to provide faster feedback to their dev team. But in any case, we need test automation because if we try to manually test everything, it takes too long and we cannot really speed up the release cycles. So let's take a look at the main types of functional testing that take place today. And to do that, we'll look at a typical system that has a backend, that has an API layer, which is used by a client application, which is either a browser, a web application, or a native mobile application that the user is used to consume the service. So the first type of functional testing, a basic one, is unit testing, which is mostly performed by developers. And they test the functionality at the unit level, at the function level or class level, basically providing arguments to functions, obtaining the return value, and then asserting that it is as expected. Unit testing can be performed to validate functionality that is either on the backend or on the client application side. The next type of popular functional testing is API testing, where you focus on testing the functionality of the backend itself, of the server, where you use the API to provide inputs, obtain the outputs, and then assert again that the output is as expected. The last type of functional testing, and the most popular one, is called UI testing. And as the name implies, you perform the test using the client application, the UI of the client application, where you provide the inputs through the UI, obtain the outputs from the UI, and again assert that it is as expected. Now, this type of testing is also called end-to-end testing, because by doing this test, you actually exercise the full system end-to-end, including both the client logic and the server or backend logic. Now, it is extremely important to do end-to-end testing for the obvious reason that you could have all the different components functioning 100%, but then when you put them together, they either don't work or don't provide the desired results. So end-to-end testing is extremely important and should never be neglected. So from this moment on, we'll just focus on UI testing. Then again, as I mentioned, it's the most widespread type of functional testing. This is the type of testing that is being done with tools like Selenium, Appium, Cypress, and dozens of other excellent frameworks that exist for this purpose. We test the end-to-end functionality of the system through the UI. We don't test the UI itself, but actually the functionality of the system. And a test is basically built from a sequence of steps in which you first simulate some user input, like navigating to a certain page, clicking some elements, entering some text, and then validating the output that the system produces on the UI, and make sure that it is as expected using assertions. So let's take a look at a very simple example, functional test that almost every system needs to implement. Given that a user attempts to log into the system without providing the username and password, we expect the system to show error messages that indicate that those fields are required. The way we would implement a typical UI test for that with Cypress is as follows. Now, for those of you who are not familiar with Cypress, it's a very simple test and it looks just about the same in every other framework, so I'm sure you'll be able to follow. Basically, in line number 3, we navigate to the login page. In line number 5, we locate the login button and then click it. And then in lines 8 to 17, we have 3 assertions where we make sure that basically there are 2 error elements and they have the correct text, which is required. And we also make sure that the login button is still available on the screen so that the user can actually try to correct what he did and try to log in again. So a very simple test that covered this functional requirement. Now, what happens if some developer on the team, another developer on the team, or in a different team changes the CSS that determines the style of this login page and inadvertently causes the login button to change? You can see the difference in the text and the size and the background of the button. Now, this is what we would call a visual bug. The system still functions, only that the login screen doesn't look the way that it should. But what would happen if the same CSS change would actually cause the color of the error messages, of the text of the error messages, to be white? So maybe for the other development that actually he did what he should have and he had a different background than white, but it affected our login screen. And in this case, it's white on white, so it's basically transparent. In this case, it's a functional bug because the functionality that we are trying to validate is broken now. The user, the end user, does not see the error messages as he should according to the requirement. However, it's a bit annoying, but our test will continue to pass. The reason is that the test is validating that there are 2 elements showing certain text, and these elements are still there, and the text is still there, and so our test will pass. So not all applications are, so let's say that if I would like my test to be more robust, I would have to add many more assertions to the test, many more lines of code that actually properly assert on a dozen of other possibilities for the requirement not to be met. And that would, of course, make the time it takes to build the test and later on maintain it much longer. But not all applications are as simple as a login page. Actually, most UI pages consist of a lot of important data that needs to be validated. And this brings up a question. I mean, look at this, for example, at this application. We need hundreds of assertions of validation code, lines of validation code in order to assert everything that is shown here. I'm not even talking about the graphs and the charts. I'm just talking about the things that are easy to assert, right? It takes a huge amount of code just to be able to validate everything that's on that specific page. And if we look at, for instance, this Gmail inbox, so there's so much functionality that is being presented in this single state of the application. The fact that all the correct email folders appear, the fact that all the emails appear in the right order, they're sorted by date, the fact that we see the correct list of recipients, the fact that the summary of the emails is correct, the people that are online at this moment. So much functionality. Again, we need hundreds and hundreds of validation, of lines of validation code in order to assert everything that goes here. And then, of course, we write all these validations and all these locators that are used to locate and find the elements that we want to assert on. And then when the UI changes, what usually happens is that some of those locators would break because they are not suitable for the new structure of the UI. And then we start with the fun activity of looking at the logs from that test run. And we need to figure out if and triage the problem. Is the problem on the product side or is it on the test side? Now, this activity requires skills. It requires people that know how to read the logs. Not everyone in the team can read the logs and understand what's going on there. And in addition to that, to handle, to fix a specific test, we usually need the person or a few persons that actually wrote that test or maintained that test. They are usually the ones that are responsible for figuring out what's wrong and fixing the test. And this becomes a bottleneck because out of a big team of maybe hundreds of testers, you have very few that have coding skills and even fewer that maintain those specific tests and can handle them. And these people need to basically stop what they're doing when things like that happen. And instead of implementing new tests that cover new functionality that we've added to the system, they now need to spend a few hours investigating the reason for the failure and start maintaining and fixing the broken tests. So this brings us to the reality of test automation today that is from what we see in the industry is happening, where most teams basically struggle to succeed with UI testing. So every assertion that you add, every single assertion that you add increases the maintenance overhead, and it brings teams to consider and think twice before adding it. They would start questioning, is the feature really important? What is the risk of having a bug in this feature? How likely it is that we'll have a bug here? Perhaps it's not worth automating and it's better off testing manually. So it's not obvious at all that we need and can automate everything. As I mentioned before, the fact that coding skills are required to create and maintain tests is a huge bottleneck for most teams and a huge problem. The maintenance overhead simply prevents us from writing new tests and keep up with the test coverage. This approach is also limited to asserting mainly DOM elements. There are plenty of other elements on the page, such as images, canvases, CSS graphics, WebGL, and other exotic entities that we cannot assert on with this approach. There is limited ROI in two ways. First of all, although we are interacting with the UI, we don't validate the UI itself. We just validate the functionality through the UI, so the ROI is low in that sense. But also, we can only catch expected bugs. It means that if we write a test and it has 10 assertions, the only guarantee that we get is if the test passes, then those 10 things that we expected would happen did happen. But there could be a million other unexpected things that could happen and won't happen, and the test will still pass. So because of all these reasons, manual testing is still needed. So even though teams invest in test automation and put a lot of effort in it, it still gets to a point where they cannot fully trust it. They cannot get the level of assurance that is sufficient, and they have to cover for the gaps by doing manual testing. So the approach that we are suggesting as a solution for this problem is to do UI testing using visual AI. And the way that you do it with Applitools is that basically you can replace all those functional assertions with a visual one. In this case, it's eyes check window. You can combine one of our SDKs with your existing tests and basically just use one method. What it does, one line of code, what it does is that it captures a screenshot of the current state of the application, uploads it to our servers for validation, where it gets validated with a baseline image that defines the expected appearance of the application at exactly that state. And if anything is different between those two screenshots, it fails your test. It fails your test with an exception that has a link to our dashboard. And when you go to the dashboard, it shows you clearly what changed. So in this case, the forgot password link is gone. Okay? It's very easy to see it and understand it. You don't need to be able to read logs or know how to code. And when you see this difference, the maintenance process is very simple. If this is a bug, you simply reject the new screenshot that you got, the checkpoint image, and you report a bug. However, if it's a valid change because you just added a new feature, then you just accept the new screenshot, so it becomes a new baseline for subsequent test runs. It is as easy as that, and it doesn't require any coding skills, so everyone in the team that knows the product and can determine if a change is right or wrong can do the maintenance. Now, visual assertions have several important advantages over the traditional functional ones. First of all, instead of writing, usually there are few assertions, but if there are many of them, it's even with low coverage, but if there are many of them, it saves even more maintenance effort. But you write a single assertion, a single line of code that gives you complete functional coverage for everything that is displayed on the UI at that point. Another important, so it takes really a fraction of the effort to create new tests and to maintain them while getting more coverage. Another important advantage is that when the UI changes, the test code doesn't break. You don't need to go and fix the code, especially because, as you can see with the assertion here, it doesn't have a locator. It is completely independent of the structure of the UI. All you need to do is go to the dashboard and accept or reject the difference. The fact that you don't need any coding skills to do that means that everyone in the team can work together to maintain the tests. Everyone who knows the product can do it. And there is no longer a bottleneck for having those tight familiarity with either the test or having the coding skills to do it, which frees up time for the test automation developers to build more tests and to get more of the functionality covered. As I explained before, the fact that you actually compare the entire page, the entire screenshot with the baseline means that you'll start finding unexpected issues, unexpected bugs. It's not 5 specific assertions that you check for everything. And if anything changes, you'll know about it. So you'll be able to get a lot more value out of your existing tests. A bonus on top of all of that is that by taking this approach, you're also validating the UI itself, not just the functionality. which gets us into the realm of visual testing. But this is not the focus of this session, so we won't dwell into the details here. To back up my claims with some data, I want to share with you some empirical evidence from the Applitools Visual AI Rockstar Hackathon that we held about 2 months ago. Here is some, in this hackathon, we had 1,000 participants, and we asked them to accomplish 10 common test automation challenges, to do it once with a traditional approach and once with using visual AI, using the technique that I just showed you. Now, here's some numbers, some statistics that we collected from 288 participants that actually completed the hackathon. And this includes the 10 best completions that won the grand prize. So in terms of the time it took to implement the test suite, it took almost it was 5.8 times faster to complete the tasks with visual AI. And for the winners, it was almost 8 times faster, which is a huge productivity gain. In terms of total lines of code, on average, the participants, it took them half the amount of code to complete the challenge. And the best participants actually saved 72% of the amount of code. If we consider locators as a source for instability and future maintenance overhead, then on average, there were 4.6, the tests are 4.6 more stable. It means we had 4.6% less locators used, and it was 6 times more stable for winners. And in terms of the coverage, the eventual coverage and bugs found with the test suite that was written, then using visual AI, 95% of the bugs were found versus 65% using the traditional approach. And for the winners, they got to 100% coverage. Now, these are very impressive numbers. However, it's important to take into account 2 more factors. First of all, the people that participated in this hackathon were test automation practitioners. These are people that have years of experience doing test automation the traditional way. And this was the first time that they were exposed and tried out the visual AI approach. And even though they had a lot of experience with the other approach and just started out with the new one, they did so much better using the new approach. Second, you can see that is relatively not a big difference between the overall performance of the people who completed the hackathon and the 10 best ones. Okay, this means that every test automation practitioner can actually get to these productivity gains. You don't have to be super experienced or super talented to be able to get to those high gains in productivity. Anyone can basically, every practitioner can basically enjoy them. So this is a demonstration, an empirical demonstration of the superiority and benefits of this technique. By the way, next week we are going to publish all the results of the hackathon, including all the statistics and measurements that we held. And I know that all of you will get an email with a link to all these statistics and details in case you're interested in viewing it later on. So to conclude this part of the talk, from what we've seen interacting with many teams, development teams across different businesses and different sizes of companies, basically everything that you do today with UI testing using the traditional approach can be done with visual AI, with visual testing, only that you get more coverage and it takes a fraction of the effort to create a test and maintain them. And when we see situations where as parts of a UI test that cannot be translated to a visual test, this is most often an indicator that you're doing something in your test that doesn't belong in a UI test. It could have been done better in a unit test or in an API test for most of the cases. So this is definitely the correct picture that we've been seeing and observing in the past few years and know from our own experience. Okay, I'd like to switch now and talk a little bit about visual AI, what it's all about, and what can it do. So of course, in order for this thing to work, it has to be extremely robust and accurate and stable. And although we are not 100% accurate, today we're at a level where we have a single false positive out of every 1 million checkpoints, which is very, very, very accurate. And we'll continue to invest in this technology and improve it all the time. So it's getting better. Now, basically what visual AI does is that it emulates the human eye, the human vision, and it aims to look at computer screens just like a human would. And this has various, and in order to do that, and it's important to do it because there are a lot of differences that you would see at the pixel level that we as human beings are not aware of and we cannot see it. So there are dozens of these situations. I will just to give you a taste, let's look at a feature called AntiAliasing and show it as an example of some of the things that you have to be able to take care of flawlessly if you want to robustly be able to compare screenshot in the way that we do. So let's look at the example that we see over here. We have a navigation bar at the bottom of the screen, and there is a playlist tab there. And you can see that the text, the playlist text is white. And if you would look at the DOM for that page, we would see that the color of the font is white. But if we look at the magnified pixels, you can see that there are many pixels that have different shades of blue. Okay, these are anti-aliasing pixels. Their purpose, they're added by the graphics card, and their purpose is to make the font, the text look smoother to us, so we don't see all these jagged edges of the pixels. Now, anti-aliasing is a fantastic feature. The problem is that when you show the same exact page with the same exact code on a different computer that has a different graphics card or a different driver version, or a different screen connected to it, or many other things that can be different, you'll just get different anti-aliasing pixels. So if I toggle between the two, you can see how severely different the anti-aliasing pixels can be, but still the original playlist text in its normal size, we don't see any difference. This is because we cannot see this difference of pixels. Now, visual AI is capable of understanding that although there are so many different pixels here, it's basically invisible and it will never alert that something changed here. On the other hand, if a plus symbol changed to a minus symbol or a comma changed to a period, that could be just 2 or 4 pixels on a small font, it will highlight it because it can understand that this is something that is very much visible to a human being. And there are many other examples. I won't go into all of them. Other important capabilities of this technology are critical in allowing you to do maintenance in an efficient way. For example, let's say that you've changed the UI of your screen, changed the margins between elements, or just added a new part to the screen. In this case, everything will shift, and if it would just show you a huge mark the whole page as changed, it doesn't really help you understand what happened. So visual AI technology can actually show you the root cause of what really changed here, and quickly pinpoint you to that location, and making sure that you are able to easily identify the change and not get mixed up in situations like that. Another critical aspect is what we call functionality, is what we call automated maintenance, test maintenance. The idea here is that there are maintenance activities that are repeatable, and we use sophisticated algorithms to help us do the dirty works for you. So, for example, let's say that you introduced a change into the system, or there is a bug that occurs many times. It could occur in different screens, in different steps of your test, or if you are running cross-browser or cross-device, it will occur in all those different devices and browsers or viewport sizes, etc. So instead of having to look at the same difference again and again and again and approve or reject it, you can just ask the system to just show you unique differences. So in this case, even if it's appeared 1,000 times, you only need to look at 2 differences, one that has the difference, one that doesn't have it. With a few clicks, you are done rejecting or accepting all the occurrences of the difference and updating your baselines. So there are a lot of features like that in the system that allow you to really increase the amount of tests that you have, amount of visual validation points, but without really increasing the maintenance overhead. Another important ability of visual checkpoints that today is limited to testing web applications, but in the future will also apply to a native application, native mobile application, is what we call root cause analysis. So together with the screenshots that are uploaded for validation, we also upload the DOM and the CSS. And when you zoom in on a difference, we can actually show you what changed in the implementation of the page that caused that difference. So this can actually save developers, in some cases, hours of work trying to triage and understand and figure out the cause for a bug. If the bug doesn't reproduce on every run, it saves them the time needed to reproduce it. If they need a special environment to set up, it saves them the time to set up that environment. If another developer caused the change, the developer that is handling the case has no idea what's going on, he needs to look at the code and try to figure out what's causing it. Sometimes it's not clear. You need to go back in source control and find the previous version that worked and try to find a diff to get a clue of what changed. All of this is made unnecessary with root cause analysis. You just click on a diff and you see exactly what caused it, and it goes far beyond just telling you that the color of the button of the text changed, because you can see that on the image. It will actually tell you that a certain class was added or removed from a parent container, and because of that, certain CSS rules were added or removed. So it gives the developer exactly what it needs to immediately solve the problem. And it gives QA personnel, QA engineers, the ability to report bugs that include all that information out of the box. Now, the example that I showed you was with Cypress. It's important to highlight that this visual AI is a universal technology, and we support all the existing programming languages, all the popular automation frameworks, either they're used by developers or testers, whether they apply to web development or native mobile development. It can just work with images. So whatever technology that you're using, as long as you can get an image and it has some kind of digital user interface that can be validated, the technology will work with it. It works with PDF files to validate them, anything that has an image. And we are continuously developing support for any new framework that will come up. So no matter what tech stack you're using, or whatever new fancy tool will come out in the future, we will support it, and this approach will still be valid. So I'd like to now talk about cross-device and cross-browser testing. Once a team already has, oh, okay, I just saw the message here. Okay. Once a team already has test automation in place, the immediate thing that he wants to do is run those tests on the same devices and browsers that his customers are using to interact with the application under test. And that's a very logical thing to do. You want to make sure that you're testing your application in a way that guarantees that your users benefit from it, right? It's very obvious. So what are the options that you have in order to make that happen? So the first approach, the first option is basically to run the test locally on your dev or on your personal test machine. Basically, what you're doing here is that you're running the test locally. The test spawns up a browser, for that matter, locally on your machine. The browser interacts with the application and the test that resides, again, behind the company firewall in many cases, and you're able to test it that way. So this approach has a few advantages. Of course, the test is fast because everything is happening on a single machine. The test code is interacting with a browser that is local. It's fast, it's stable. It's also secure because all the communication, everything happens behind the company firewall. However, there are a few disadvantages. First of all, the tests are running on your dev machine. You cannot develop. You have browser screens popping up or CPU going up, so you cannot really work there. That's a minus. It's difficult to scale your test if you want to run 10,000 tests, and there is a limit to the amount of browsers that you can open on a single machine, so it's difficult to scale. And if you want to test on different platforms, you need different operating systems, different devices, so that's very difficult to accomplish on a single machine. So the next option that is possible is to basically build a lab, internal lab in your organization that has different VMs and devices that serve the R&D team or the testing team to run the tests. And then on your build machine, you just have the tests running, and they interact with browsers and devices that are in that lab. And those browsers and devices in turn interact with the application on the test. And then again, because it's local to your organization, then of course everything is still behind the corporate firewall and it is secured. So we have many upsides to this approach. As before, everything is running on a company local area network, so it's fast and it's stable and it's secure. You can scale it. It's not tied to a single machine. You can have multiple platforms. However, there is one big problem to this approach, which is it requires a huge amount of maintenance and expertise. So managing all these platforms is a very challenging task. It requires a lot of effort and dedication, manpower. You have to keep it updated with the new releases, the browsers, and all the dependencies and the operating system have leaks in them. They need to be constantly refreshed, and you need the ability to reset the machines over time. It requires like full-time maintenance and treatment and taking care of, and this is not, let's say, it's very difficult to develop this skill set within an organization. It takes a lot of effort, and it's not tied to the organization, main line of business. So it's just wasting effort and time and money for suboptimal service at the end of the day. So really, there are very few companies that are doing it that way. What most companies are doing, that they're working with a remote lab, with one of the lab providers. There are several of them. And what is done there is that basically everything is as before, just that the browsers now are hosted by the lab provider, the browsers and devices, and our test code interacts remotely with those browsers that in turn interact with the application and the test. However, there is a problem here that the browser are outside the corporate firewall and the application and the test is inside it, and this leads to several disadvantages. So we get the scale, we get the platforms. We don't need to invest effort in maintenance, we just pay the vendor. However, there are downsides. First of all, right now, those browsers could be located at the other side of the continent or the other side of the world. And every interaction that our test is doing with the browser, every interaction with every element, every click, every mouse movement now is an HTTP request that goes all the way to that remote browser. This means that tests are much, much, much slower. This means that there is a lot of opportunity for instability in the form of timeouts and latencies and packets being dropped on the internet. And of course, the fact that you need to have browsers outside your company having access to applications inside your company poses a security concern. So what is this security concern that many teams are afraid of? So in order to test the application understand test from the outside, you need to allow inbound network access from the outside world. All vendors also offer secure tunnels, but these tunnels just, again, allow that access, maybe with a little bit less IT hassle, but they are just as insecure as allowing inbound network access. And the big worry here is that the remote virtual machine is basically an unmanaged asset as far as the organization and the company is concerned, because you can load any software that you want into those VMs in order to run your tests, any dependencies, so basically any code can run there. Those VMs have free access to the internet, and they also have access to your internal network. So basically, if someone attacks or gets hold of this VM, he basically can do anything that he wants to, given this access control. Now, this is very problematic for many companies, because if they have to they obey to some compliance and regulations, then basically they can, and they work very hard to make sure that their own network is secured. They have to rely on the vendor to keep his VM secured, but they don't have direct control on how good of a job he's doing there. But besides all this slowness and the security concerns, why are we really running this test? What is the ROI? What are the bugs that we are trying to find? If the bugs are on the server side, then of course it doesn't matter what device or browser we are running on. We'll find them. If it's a broken database query, a logical error, some kind of a performance issue, we can even test it and find it at the API level. It doesn't matter if we run it on 20 different browsers and devices, this failure will occur in all of them. So we don't need to use this approach of cross-device and browser testing to find server-side bugs. And when it comes to the client-side bugs, then what we see from our own experience and many teams that we spoke with is that most of the client-side bugs are always device and browser agnostic. So if the bug happens in one device or browser, it will happen on all of them. The reason is that today most browsers conform to the W3C standard, so it's not like maybe let's say 5 years ago that the server would actually serve a different application depending on the browser. Today this is very rare, and even if there are tweaks, they are pretty minor. So it means that the logical bugs will occur on all client environments. If you're not validating an input field, all the tests will fail. If you not sorting the output or the list in the proper way, it will fail on all the devices, all the browsers, etc. So there is really no value in that case to run all your tests on all these devices. There are some exotic things that you can find that are device specific. Let's say you want to, there is a certain complex gesture that you want to make sure that works on specific devices, or maybe you want to check what happens to your app on different devices where there's an incoming call, or how you consume the battery of the device. But then again, these are very specific things that you want to measure, and you can write 2 tests that cover all these scenarios and run them on 20 devices. But then again, if you have 10,000 other tests that just check like normal functionality, there is really very little value in running them against so many devices and browser combination. Now, the real value that is worth testing across all these devices is the UI itself. Testing the UI itself, because the UI is indeed extremely sensitive to this change in viewport size and pixel ratio. So it's very likely that if the UI looks good on a device of a certain size, if the width of the screen is smaller, something will get out of the screen, or fall downwards and cover another element, or corrupt the UI. And it's definitely possible that if the UI looks good on IE, it won't look good on Firefox, or that if the application works on Android, the application on iOS won't work. So this is where the real value is. But then again, if we're interested in functional testing, then this is not what we're testing when we run cross-browser tests. So the reality is we see it when it comes to running cross-device and cross-browser testing, is that most teams are very unhappy with the remote test lab setup. The tests take much longer to execute. They are less stable due to the delays and timeouts and network failures. There are the security concerns that I mentioned. And on top of all that, we need to run every test multiple times, right? If I want to test my login test on 20 different clients, I need to run the login test 20 times. And this means 20 times more failures, more time to analyze test failures, more time to wait for test results, more time. And if I want to speed that up, I need to pay a lot to get more concurrency going. And at the end of the day, I get very low ROI because, as I mentioned before, there are hardly any bugs that other than UI and visual bugs that are specific to the client. So the solution that we provide to that, to getting the actual value out of cross-device and cross-browser testing, is using the Ultrafast grid. And the Ultrafast grid is basically a grid of devices and browsers, and an innovative grid that works very differently from the traditional grids that have been out there for a decade or more. The way that it works is as follows. You run your test. Let's go back to the simple scenario of running on a dev machine. And that test is running locally, and it spawns up a local browser. And this browser interacts with the application on the test. Now, when you have a visual checkpoint, as I've shown you before, instead of grabbing a screenshot of the application at that state, what the SDK is doing is it actually getting all the resources from the browser, all the CSS, DOM, fonts, images, everything that's there, and uploads the delta to the Ultrafast grid. What the Ultrafast grid is doing is that it then spawns up the devices and browsers, and in parallel, it renders the screenshots on all these devices and browsers, and you run the test once locally, and as a result, you get the test results, the functional test results and visual test results on all the different environments that you wanted to test on. Okay, so basically you have a single test that gives you the coverage of all those environments. It's very easy to set up. You just list the environments that you want to run on in your test, and it has many advantages. It covers all the environments at the speed of running a single local test. It is much more robust and stable because you're not running the test 20 times, and almost no data is being passed over the network, and the interaction with the browser is still local and reliable. You get the full functional and visual coverage, as I mentioned before, with Visual AI. There are no security vulnerabilities. You can see that it is not required for the ICE server to have access into the corporate firewall to gain access to the application and the test. It also reduces test data preparation and consumption. So if you need to do some setup and teardown before each test, then the mere fact that you don't need to run each test 20 times means that you don't need to set up and tear down 20 times. And if you need to allocate resources for the test, such as a new user, then you don't need to allocate 20 new users, but one is sufficient. It does not load the corporate network, which is also an important IT gain. And not less important is the fact that this grid costs much less than a traditional grid. So let's see the Ultrafast grid and Visual AI in action. What we'll do is that we'll run a simple Cypress test that, let's look at the functional version of it, the traditional version of it. We go to Wikipedia, navigate to wikipedia.org. We type in functional testing, and then we get to the article on functional testing, and we make sure that the article title is actually functional testing. Okay, so that should be testing. Now what we would do is that we would, so basically we would get to this page, write functional testing, get here and make sure that the text here is functional testing. Now what we would do is turn this into a visual test, a functional test with functional AI, with visual AI, sorry. And the way that it would look like is as follows. At the beginning of the test, we just call eyes open, indicating that we are starting the test, provide a name for the test and a name for the application, and then list the different devices and browsers that we want to test on. We have a few form factors, viewport sizes for Chrome, Firefox, i11, i10, Safari, and some devices in different orientations. And then we just do as before. We visit wikipedia.org, type in functional testing, but instead of just asserting on the title of the article, we actually do a full page visual assertion and complete the test. So let's run this test using Cypress. You can see that on the previous run, it took just 32 seconds to run. So the test is running. You can see that it ran just once, right? It's not running now 15 times. It's just ran once. We're now waiting for all those renderings to occur, getting those screenshots ready and running the visual tests and comparing them with the baseline image, basically giving us full coverage of that page. You can see that it took only 26 seconds to run, which is super fast. And if we go to the eyes dashboard, you can see that we have a new batch here with new batch results. You can see that it does cover all the different browsers and devices that we have listed before in our tests. And if we go back, you can see that we have here the images in all those form factors, that everything on that page, which is a huge amount of detail, everything is being validated with that single line of code. Now it would take me maybe 3 minutes to turn this existing functional test into a visual one, get all that coverage, and you can see how fast it is to execute. In 26 minutes, 26 seconds, I got coverage on 15 different browsers and devices. So to conclude, with functional UI testing with visual AI, the takeaways that I would like you to get, and I hope that I convinced you, you can drastically increase test coverage and find unexpected issues, drastically reduce test creation and maintenance time, reduce test execution time. We support all the frameworks that you are using today or will use tomorrow. And of course, it also can reduce your test lab costs in addition to all those improvements in ROI. So with this, I've concluded the session. I'll be happy to take your questions.
Great. So we have quite a few. We'll try to manage as many as we can until the top of the hour. So first of all, just a moment before we start the questions, I forgot to mention during my housekeeping, because we did get a lot of questions about that. Yes, you will get, we are recording the session and you will get the recording emailed to you by Monday. Also, I see a lot of people asking for visual testing demos and ultra fast grid demos. So obviously, one of our solution architects will be in touch with you after the session to do those. We're not going to do another one with Adam right now, so we're just taking questions. Of course, if you want any demos, ping us in the questions panel, and we'll get in touch with you. So questions, we got a lot about resolutions. So how does the comparison with the screenshot work if you try to test different resolutions? Would I need a corresponding screenshot for each resolution, or can eyes take that into account?
Okay, so I'll answer it together with the visual grid. So basically, you don't need to do anything special on your side. eyes takes everything into account. So basically, if you specify, let's say with the visual grid, these different form factors, viewport sizes, etc., then simultaneously the grid will produce the screenshots for all these variations. They will be automatically compared with the corresponding baselines, and you will get all that coverage, and you don't have to do anything in your test besides specify which resolutions and operating system and browsers you want to work with. In addition, the automated maintenance functionality that I've shown you before makes sure that you don't have extra overhead maintaining those baselines, because if something changes in one resolution and it also changes in the other, it's sufficient to accept or reject it once. Automated maintenance will make sure that it gets accepted or rejected in the other baselines as well. Next question.
How does the ultra-fast grid different from cross-browser testings with Sauce Labs or Browser Stack?
So I actually spent a lot of time explaining that, but the basic difference is that cross-browser testing with a traditional grid, every test on every device, you run the test separately. So if you want to test your login test on 20 devices and browsers, you need to run the test 20 times. Okay, and with a visual grid, you run the test once locally, and we grab the resources and we actually inject the state of the application, the specific state of the application in each assertion into the appropriate devices. And there, in that point, we can render the image and validate that everything is as expected in the baseline. So the test only run once locally, and you get the coverage for all the environments. And the benefits in speed and stability and all of that comes from the fact of the different way that it works, that it functions. That's it.
Okay, my service is very text heavy, so it has massive amounts of text, and many of the articles are written in several languages, not just English, let's say Korean, etc. Does visuals testing, can visual testing test that, and with a meaning of, can it test a lot of foreign languages and pages with a lot of texts?
Yes, definitely. So it's extremely useful for testing localization. There are various ways to do that. I don't want to spend too much time talking about it, but in general, you can have a baseline for each language, and therefore, when you run your regression test, you can be sure that nothing changed in the languages that you don't understand. And if something did change, instead of going over the entire application, it shows you exactly what changed and where. You can share this link with the language expert. He can simply approve or open a bug if it's wrong. It's super easy to maintain. It saves 99% of the effort. And we have many customers that do their localization testing that way, and it's a huge time save for them.
And since we are out of time, I think we'll take just one last question. As I mentioned, we have a lot of questions here, so all of these will be answered via email after the session. How does eyes identify which part of the page we want to check?
Okay, so by default, it takes a full page screenshot. That is the entire page as a whole. If you want to focus on a specific part, you can actually use the SDK and point it at a specific element on the page, and then only that element will get tested. If you are testing a big page and there are areas there that you want to ignore, it's very easy to specify them either from the dashboard itself by drawing what we call an ignore region directly on the baseline, or programmatically through the SDK, indicating the locator of the part of the page that you want to ignore.
So unfortunately, that's all the time we have for today. Before Adam says his goodbyes, I want to thank again to everyone that joined us today for this live session, and of course, thank Adam for this in-depth presentation. As I mentioned, the recording will be sent to you by end of day Monday, and I do hope to see you at our next event. Stay safe till then.
Thank you very much, everyone, for joining. Be safe.